Okay, we're going to talk a little bit about how we analyze that chart that we had on our test the other day with the periodic table when we're talking about isotopes and ions. First, let's be clear on what an isotope and ion is. An isotope is when you have a different number of neutrons, but it must be the same atom. So the atomic number, the number of protons needs to be the same, but the number of neutrons are different to each of them. So you have to have the same atom to compare. Ions, on the other hand, have different numbers of electrons. So they can either be negatively charged if they have more electrons or gain them, or positively charged if they lose an electron. All right? So that's what an ion and an isotope is. To first figure it out, we must fill in the very top part of our graph here. Okay? So let's look across the top of the graph and see what types of information we need to fill in there. The first bit of information is the number of protons if that's empty. We know that the number of protons equals the number of the atomic number on the periodic table. So those two numbers will be the same. We also know that your number of protons and electrons should equal each other. So in the electron column, if that's blank, it should be the same as the protons. So that way you know how to calculate those. Your number of neutrons are determined by taking your atomic mass minus your atomic number. The atomic number is the same as the protons. So if you have one of those, you can figure out the other. The atomic mass is a little tricky. It's taking your protons and adding your neutrons to them, and that will give you the atomic mass. So we have atoms over here, and the atoms that we have are QWE, RTUN. Right? Those are the different atoms that we have that we're going to be looking at and filling in the blanks on the chart. So atom Q is right along the top there. And the interesting thing about atom Q is that we have the first three items filled in. We have a 12, 12, 12, and then we have a blank atomic number and a blank atomic mass. We already said the atomic number must be equal to the number of protons. So we know that the number of protons is 12. So therefore the atomic number must be 12. The atomic mass, remember we said, was your neutrons plus your protons. So I have 12 protons and 12 neutrons. So I have atomic mass of 24. So in my top row there, the two numbers that I filled in are 12 and 24. The second row is the atom W. We have 6 protons, our number of neutrons is open, we have 6 electrons, our atomic number is open, and our atomic mass is 12. So let's first look at our atomic number. It's open, we don't have it filled in. So it has to equal our number of protons, which if you look at your chart, the number of protons is 6. So that atomic number then needs to become 6 on there. The other number that is open is the number of neutrons. We said that we get the number of neutrons by taking our atomic mass minus our atomic number. Well, our atomic mass in row W is 12, and our atomic number is 6. So 12 times minus 6 is 6. So your number of neutrons is 6. So going across W, it should be 6, 6, 6, 6, and 12. Now, let's look at E. We have 2 blanks there. We have our number of protons that is blank, and we have our atomic mass that is blank. We know that our atomic number is equal to our number of protons, which is blank, is equal to our atomic number. The atomic number in this case is 6. See that? It's already filled in, is 6. That means my number of protons has to be 6. So in E, you need to fill in 6 for that number. To find my atomic mass, I got to take my protons and my neutrons and add them up. I have 8 neutrons and 6 electrons, which means I'm going to end up with 14 as my atomic mass. Now let's look at our element R, as in Richard. I have a blank for my atomic number. I have 0 for the number of neutrons, 1 for the number of electrons, 1 for the atomic number, 1 and then the atomic mass is blank. So first of all, we have our protons is empty. So we know it's the same as, yes, our atomic number. We've said that over and over. So our atomic number here is 1, which means my number of protons is going to be 1. The other item that's missing here is my atomic mass. Again, protons plus neutrons makes my atomic mass. So in R, I have 1 proton and 0 neutrons, which gives me an atomic mass of 1. And so that would go there. So going across R, we have 1, 0, 1, 1, 1, all the way across. Now let's look at T as in Tom. We have 17 protons, our neutrons are blank, and our atomic number is blank. Now, again, our atomic number is equal to our number of protons, which is 17. So therefore, in my atomic number, I need to put the number 17. The other number that I'm missing here is the number of neutrons. We know that the number of neutrons is your atomic mass minus your atomic number, right? We know that. So that means that we have 35 minus 17 gives me 18 for my number of neutrons. So in T, it should be 17, 18, 18, 17, and 35. Now, let's look at U. We're missing my number of neutrons and we're missing my atomic number. Again, atomic numbers and protons are equal. It gives me protons here. The protons are 11, which means my atomic number should be filled in as 11. The other thing that is missing is my number of neutrons. Again, atomic mass minus atomic number, which was 23 minus the 11, and I get a 12 that I need to put in there. So U, I have 11, 12, 10, 11, and 23. Now let's look at M as in Mom. I have my protons is missing and my atomic mass is missing. Now I know my protons, again, is equal to my atomic number. My atomic number here is 9, so that would make my number of protons 9 also. So I'm going to fill that in. The other thing missing there is my atomic mass. The atomic mass is your neutrons and your protons added together. And here I have 9 protons, and 10 neutrons. So that's 9 protons, 10 neutrons. It gives me an atomic mass of 19. So here's what your chart should look like right now. All right, everybody see that? We filled that in. It's essential that you fill this top chart in correctly so that you can answer the questions on the bottom. Without that, you're not going to be able to answer them properly. The first question on the bottom says this: which 2 substances are isotopes, and explain how you know? Well, first of all, if something is an isotope, we know it has a different number of neutrons, but it must be the same element. I can't have carbon and nitrogen can't be isotopes of each other. Carbon 12 and carbon 14 can be isotopes of each other. So I first need to look on my chart and find what items, if any, on my chart are the same element, which means they have the same atomic number. So let's find our atomic number column, and let's look down and see, are there any there that have the same atomic numbers? Well, if you look, W and E, where the slashes are by, both have the atomic number 6. So they are the same element. So the next thing that we need to do is you need to look on W and E and see, do they have different numbers of neutrons? Well, one has 6 and one has 8. So they do have different numbers of neutrons. So W and E are isotopes of each other. Why? Because 1, they have the same atomic number, and 2, they have the different number of neutrons. The second question says, what are 3 substances that are on there that are ions of each other? That means, or not of each other, they're just ions. So they need to have different number of electrons than they do protons. So you're going to look at these 2 columns where my fingers are, protons and electrons, right? You're going to look down those, and you're going to see which three of those have different numbers of protons and electrons. So let's look at if there are what three have different numbers. So let's look at Q. Protons and electrons, they're both 12. Can't be that. W, they're both 6. Cannot be W. E, they're both 6. They cannot be E. R, they're both 1. They can't be R. T, 1 is 17, number of protons, 18 electrons. Different numbers, therefore it's an ion. U, I have 11 protons and 10 electrons. Different number, therefore they're ions. M, 9 protons, 10 electrons. Different number, therefore they're ions. So the three that are ions are T, U, M. Why do I know that? Because their number of protons is not the same as the number of electrons. That makes them an ion. You need to have both parts of both of those questions to get them correct. The third question goes back and asks you to look at those three items that you said were ions and tell me which one of those is a positive charge. We know that if I lose an electron, I get a positive charge. If I gain an electron, I get a negative charge. So I'm looking for whichever ones of those has less electrons, because that would make it positive. So let's look at each one. T, I have 17 protons and 18 electrons. I have one more electron, so it's a negative charge. U, I have 11 protons, 10 electrons. Less, which means it's positive. So the positive one here is U. Why? Because it lost an electron and therefore it has a positive charge. So the answers to each one of these is, the first one is W and E because they have the same atomic number but different number of neutrons. The three ions are TUM because they have the number of protons is not the same as the number of electrons. Which one of those ions is positive? The answer is U because we lost an electron, therefore it has a positive charge. Now, the chart that you're going to have on your quiz tomorrow is not going to be the exact same chart with the same numbers. It's not going to be the bottom three that are going to be correct or whatever. You need to go through the same process that we went through today so that you know how to do them. Good luck. I know you can all do this. So good luck tomorrow, and watch this as many times as you need so that you know what you're doing.